This video is going to show you how to work problem 7.10 in Siegel, which is about discrete probability distributions. So let's read through the problem. You have identified four major problems, the extent to which each one occurs, that is the probability that this problem will occur per item produced, and the cost of reworking to fix each one. Assume that only one problem can occur at a time. So the way to think about this in the context of chapters 6 and 7 is that you're doing a random experiment. A random experiment is that you inspect something that you just made. So you just made one of these widgets, you inspect it. Now this random experiment can have several outcomes. You know, your inspection could identify that the case is broken. It could identify faulty electronics. It could identify that the connector is missing. It could identify a blemish. So these are the four outcomes. Outcome is that term from chapter 6. Now, let's move on to chapter 7. So what have we done in chapter 7? Well, we've added random variables. Random variable assigns numbers to outcomes. So in this case, we're going to have a random variable x, which is the cost to rework something. So if the outcome from my random experiment is that I declare the case broken, the cost to rework it is going to be 688. We also know that the likelihood of this occurring is about 4%, and these are mutually exclusive. So I've gone over and typed this into Excel. Let's define our random variable. So x is going to be the cost of reworking an item. So one of the items that we have produced. And so I've typed this to save us a little bit of time. It says compute the expected rework cost separately, find the expected rework cost, meaning the mean, find the standard deviation, and then write a brief memo. All right, well, this is a great situation for illustrating Ed's table. So remember what Ed's table is all about. We had total down here, and then the first thing that we want to do is to sum up the probabilities. So the sum of these probabilities should be 1, otherwise we've made a mistake. So what is this? C4 through C7, and you'll see that the total does not equal 1. So Ed's table kind of catches the fact that we're missing something. What are we missing? Well, what we're missing is the possibility that our inspection came back and said the item is okay. So there were no problems. So what does it cost to rework an item that is declared okay? Well, the answer is 0. It doesn't cost anything. How likely is it that it's going to be okay? Well, it's going to be 1 minus 0.13, or 87%. Now let's go reevaluate this sum. So we're going to make this C8 instead of C7. And so now that adds up to 1. All right, so we now have our complete distribution for this random variable x. So we're to compute the expected rework cost separately and then find the expected rework. So we're going to take x times the probability of x for those expected rework costs. So we're going to take x, so this can be B4 times C4, and I can copy this down. The sum of these, I'll copy over, is going to be the expected rework cost. Let's interpret all these numbers. So what does 28 cents tell us? The answer is 28 cents is how much I expect to spend fixing the case of a randomly selected item. Now remember that for 96% of the items, so 1 minus 4% is 96%, I don't have to fix the case, so therefore I spend 0 fixing the case. However, for 4% of the items that I produce, I'm going to have to spend $6.88. Therefore, on the average, I expect to spend 28 cents fixing the case. Likewise, I expect to spend 25 cents fixing the electronics, 5% fixing conductors, 3 cents fixing blemishes, and nothing fixing items that are okay. If we add that up, we get the answer to part B, which is the mean rework cost per item. So in total, I expect to spend about 59 or 60 cents fixing a randomly selected item, and this is how it breaks out. So I might stick a currency on here just to make sure. All right, so 60 cents if you round. Part C reads, what is the standard deviation of rework cost? So let's go find that. So to find the standard deviation, remember we're going to take the probability and multiply that by x minus the mean squared. So think of the variance as being the mean of the squared deviations from the mean. So let's go find this. So we'll take probability of x, and then we're going to find the deviation from the mean. So x minus the mean, which is $9. I would reference the cell rather than typing in 0.6, because if you type in 0.6, you're introducing rounding error, and you'll get a slightly different answer than what I get. So I have to square that. So this is the squared deviation, then C4 is the amount of weight that we want to give that. And to be really picky, these should not be dollars. They should be squared dollars. So I'm going to go back and make these just plain old numbers. Now the sum of these will give me the variance. So the variance is $4.68, for square dollars and 68 cents. The standard deviation is going to be the square root of this. So let's take the square root of that. So the standard deviation is $2.16. So SD equals that. Maybe I will label the variance correctly here. All right, now let's look at the end of this. Write a brief memo. So I'll just talk you through the memo. So if we want to reduce our rework cost, where should we focus our energy? Well, let's say, for example, that we focused on reducing the number of blemishes that are produced. And let's say further that I could completely eliminate all blemishes. Would this have much effect on our rework cost? And the answer is no, not really. So it would go from 60 cents down to about 57 cents. And so there isn't much opportunity to reduce rework cost by focusing in on blemishes. Where is there opportunity? Well, there's a lot of opportunity with broken cases and faulty electronics. If I could eliminate broken cases altogether, that would cut my rework cost almost in half. And the opportunity is almost as great with reducing these electronics. So if I want to focus my energies where I can get a big payoff, then I want to focus on those two activities. So this may be a quality control example, but the same thought process is really important. You could be trying to figure out which media is going to be more effective in reaching your consumers. Well, you want to find out which one is going to have the biggest payoff in terms of the effect on the outcome you care about, like sales. So it's all about prioritizing where you put your energy. Okay, so that's a good illustration of Ed's table.